Okay, let's recall the absolute value function. So we know the absolute value of a, or for example, if we take the absolute value of -2, we know that means 2. The absolute value of 2 is also 2. Sometimes we define the absolute value in terms of, we draw the number line, we have 0. If I want to know the absolute value of 5, it just means the distance from 0 to 5. If I want to know the absolute value of -4, it just means the distance from -4 to 0. And by distance, we mean something that's always positive. So that's how we indicate that the absolute value function is always positive. So the absolute value of -4 is the distance between -4 and 0, which we define to be positive. So it's 4. Anyway, we know about the absolute value function. So let's take these two here. If we put in a positive number into the absolute value sign, we get the same thing back. So if we put in a, and if a happens to be positive, then we just get a back again. Just like when we put in 2, we got 2 back again because 2 was positive. On the other hand, if a happens to be negative, then what happens? When we put in -2, we don't get -2 back again. What do we get? We get 2. So if a happens to be negative, that's what we've written here, we don't get, just like here, -2, we don't get -2 back. We get 2. What's the relationship between -2 and 2? How do I transform -2 into 2? I take -2. So in other words, if a happens to be negative, then I don't get a back again, but I can say I get -a back again because a is negative, so negative will give me a positive number. So this works. So we can write that. In other words, we can write this. If a is greater than or equal to 0, we can put the equal to it. It's not going to make any difference. If a is greater than or equal to 0, then the absolute value of a is a. If a is less than 0, then the absolute value of a is -a. But when I switch the order, here I put the if first, here I put it here, that suggests a piecewise defined function. So, in other words, we can say that the absolute value of a suggests it can be written as a piecewise defined function. So we would say what? It's equal to, and there's two pieces. If a is greater than or equal to 0, we one thing, and if it's less than or equal to 0, we do something else. So we want to write as a piecewise defined function. We want to say if a is greater than or equal to 0, we write it as a, but if a is less than 0, and by the way, you could change these. It doesn't make any difference. You could put the equal to part down here. It wouldn't make any difference. Anyway, here you get that. Okay, so absolute value function can be defined as a piecewise defined function. And if we want to make the graph of it, we would say, okay, well, what does it look like? So the top part, this one over here, top part here, let's call this f of x. So that's just f of x equals x, or we can say y equals x, right? A equals a. So f of x, we call it f of x equals a, or y equals x. So what does that look like? So that's just a 45-degree line like that. Okay, now the other part is here. So if we call it f of x, again, but it's a different f of x, then we get minus x, so we can call that y. So we get y equals minus x for the other part. And that looks like this. So what does this absolute value function look like? It's a v. It's a v shape. Okay, and let's just confirm that. Suppose that we ask, how about when x equals 2, we get 2. And when x equals -2, if I had drawn it right, we would also get 2. Same thing. When x equals 3, we would get 3. And when x equals -3, if I had drawn it right, we get sort of the same thing, same height here, 3. So it's a V where both of these angles are 45 degrees. So we can say that the absolute value function can be expressed as a piecewise defined function.